Hello everyone, in this video we're going to talk about how we can write some transformed logarithmic functions. So we're going to look at about 5 separate examples here, just varying types of transformations happening: a translation, a reflection, a stretch, a shrink, so on and so forth. So let's jump into number 1. It says f of x equals log base 1/4 of x. We want to translate 2 units down followed by a vertical stretch by a factor of 6. So the first thing I always like to do is write down what f of x is equal to. So we get f of x is equal to log base 1/4 of x. And now we do have 2 transformations happening, so let's end up with g of x, and we're going to use h of x as basically accomplishing our first transformation. So what does our first transformation tell us to do? Translate 2 units down. So let's say h of x would be f of x and then minus 2, right? Because translation down, that's going to affect our f of x or our y coordinates, and minus 2 would mean we're going down 2. So now we're going to take f of x, what it was, log base 1/4 of x, and just plug that in where we see it. So h of x is equal to, and now we have log base 1/4 of x and minus 2. Okay, so that's basically us applying that translation. Now we're going to do a vertical stretch by a factor of 6. So now I'm going to say g of x would be equal to 6 times the h of x, right? That's how we would denote a vertical stretch. So now I'm going to take what I have for my h of x, which is log base 1/4 of x minus 2, and we're going to multiply it by 6. Now I want to think about distributing here. So we're going to multiply log base 1/4 of x by 6. So that would just give us, so we would say g of x is equal to 6 times the log base 1/4 of x, and then minus. Now here we're going to do 2 times 6. So this is actually minus 12. Okay, so that's what our final transformed logarithmic function would look like. G of x equals 6 times log base 1/4 of x minus 12. All right, number 2 says f of x equals log base 5 of x. We want to do a vertical stretch by a factor of 3 followed by a translation 6 units down. So once again, start off with f of x. So f of x equals log base 5 of x. Now what we want to do first is a vertical stretch by a factor of 3. So let's use h of x again, and let's say h of x is going to be 3 times the f of x. So now we can take and simplify. So we would say h of x is equal to 3 times the log base 5 of x, right? We just multiplied by 3. Now we're going to translate 6 units down. So I'm going to say g of x would be what I have for h of x and then minus 6, right? So you kind of see how I'm formatting these, kind of a little bit of a pattern here, so you can keep organized as far as what's going on with your transformations. So now we can say g of x is equal to 3 times the log base 5 of x and minus 6. Okay, and that'd be number 2. All right, number 3, f of x equals log base 7 of x. We're going to reflect in the x-axis, so we have a new transformation there. And then we're going to translate 8 units left. So we've been translating up and down, now we're going to translate left. So once again, start off with f of x. It's equal to log base 7 of x. And let's go straight to h of x, and we're going to reflect in the x-axis. So remember with reflections, whatever axis you're reflecting, you're going to make the opposite axis or the opposite coordinate negative. So here we're going to say, if we're reflecting over the x-axis, we're going to make y opposite, so the opposite of f of x. Okay, so that would tell us that h of x would just be negative log base 7 of x. Okay, so now we're going to translate 8 units to the left. So when we translate left and right, it's kind of opposite of what it looks like when we write it down. Left, we're actually going to say plus 8. So we would say g of x is equal to the h of x plus 8. And now we can finish our final function here. So we'd say g of x is equal to, now we would have negative log base 7, and now instead of log base 7 of x, we're going to say log base 7 of x plus 8. Okay? All right, number 4, circle this number 4 here. F of x equals log base 1/3 of x. We're going to translate 6 left, 4 up, and we're going to reflect in the y-axis. Okay, so we're going to start off here once again. F of x equals log base 1/3 of x. And we can do these 2 translations actually at the same time. Okay, so let's say h of x is equal to, and we're going to translate 6 units left, so that's once again a plus. So we could say the f of x plus 6. And then 4 units up would also be plus, so plus 4. Okay, so now that would give us h of x is equal to, and that's going to be log base 1/3 of x plus 6, and then we'd have a plus 4 on the outside. And lastly, we're going to reflect in the y-axis. So this time we would be making x opposite. So g of x equals the h of negative x. So that's going to give us g of x would be equal to the log base 1/3. And now this is just going to be negative x plus 6, and then a plus 4 out at the end. Okay, and that'd be our final function for number 4. All right, in our last example here, we have the natural log function. So f of x equals the ln of x. We're going to translate 5 right and 3 up, followed by a horizontal stretch by a factor of 10. So once again, we're going to start off with f of x, saying that's equal to the ln of x. And we can do these two transformations at the same time again. So we'll say h of x is equal to, all right, now we're going 5 right. So that's going to be the f of x minus 5. And then 3 up would be plus 3. Okay, so now we put that in, and we would say that h of x is equal to the ln of x minus 5 and plus 3. Okay. All right, so now horizontal stretch by a factor of 10. Just like a horizontal translation, horizontal stretches and strings kind of look opposite. So if I'm stretching by a factor of 10, notice that when I put it in, or if I were looking at what the transformation is, or the value for a, because a is our variable that represents a stretch or a shrink, it's going to be kind of opposite of what I would think. So if I'm stretching, I'm actually going to plug in 1/10 for a. So now we would say g of x is equal to the h of 1/10x. Right? Horizontal means we're multiplying x, so that's why I put my 1/10 inside with the x. And horizontal is opposite of what we think because we're actually stretching or shrinking by a factor of 1/a. So if I were to look at this right now, what I have just circled, my value for a is 1/10, right? Well, the stretch or the shrink factor is actually 1/a. So if I do 1 divided by 1/10, that becomes 10, right? And so that's why it looks a little bit opposite there. That's horizontal. We got to be a little bit careful with that. Okay. All right. So now we're going to finish this off and say g of x is equal to the ln of 1/10 x minus 5 and then plus 3. Okay. And so that is how you can write some transformed logarithmic functions.